A is open circuit test for a single phase transformer. In this circuit, the secondary part here is in open circuit. Usually, high voltage winding keeps open, which is in here, and the low voltage windings connected to its normal supply, which is here. And we use 230 voltage that given. In this circuit, current, wattmeter, and voltage, resistor and inductance, also the supply, is connected to the primary transformer, which is primary coil. And the secondary winding here, we put a voltmeter to determine the voltage in the secondary winding. Usually, low voltage side is used as primary winding, which is 750, and high voltage side is used a secondary winding to conduct the open circuit. As we know that R1 and L1 we have to find by calculate them. It's already given the parameter. The input is P1 5 wattmeter 5 watt, and primary current is 60 milliampere. And we have to calculate to find the RC and XM, which is in here in open circuit. This is the RC and XM in parallel circuit. To find the power factor, we use P over VI, which is the power, I current and voltage is already given, and we just apply to the formula and we got the calculation result, which is 0.3623, and the angle is 68.7. And then to find the current of IC and IM, each we use this formula. I1 cos theta for IC, IM is I1 sin theta, which is we want to find a current through the RC and XM. This is the phasor diagram, which is the angle that we got previously is 68.758 angle, and the current of I1 that already given is 60 milli, and the IM, which is 55.924 milliampere, and this is for IC to 1.738 milliampere. And for RC that we have to calculate, we use Ohm's law to find the RC. So the current that we got through the RC is IC to 1.738 milliampere. We use that, and then the voltage supply, we use the normal supply, which is 230 volt, and we got 10.581 kilo ohm. To find the L1, we use the formula of XM, which is XL 2 pi FL. We have to find XM first. We use the Ohm's law, which is XM equal to voltage equal I, and I we use that we got is IM to find the current through the XM, and then we got 4.113 kilo ohm, and then we apply to the formula 2 pi FL, and then we apply to the formula XM equal to pi FL, which is 4.113 K over 2 pi 60 Hertz, and we got a 10.91, and then I apply to the circuit in multisim. I already put the value 10.58 K and 10.9 Henry. And the last is draw the equivalent circuit for transformer. Draw the equivalent circuit for the transformer on no load with all the calculate values. No supply and all the values that I already calculate. And we gonna run this simulation to see the result. 59.878 milliampere, 229.999 volt, 5 watt meter, 5 watt, 0.36306 power factor, and the voltage is 251.466 volt. For part B is a short circuit. For short circuit, it's already given a new value of power, which is 10 watt, and the primary current is 440 milliampere. Okay, and by using RC and XM, which is that we already calculate, to find the R1 and X1, which is R2 and L2. You can see from the short circuit equivalent circuit R1 and X1. To find R1, we use the formulas that they are given, which is P equal I1 squared times R1. And then we're gonna get 51.65 ohms. To find X1, we use the Z formula and the V over I bracket squared equal to X1 squared plus R1 squared. It becomes like this to find X1. For 22.727, which is the volt one that we already calculate by using this formula, and then we use the formula to find the V1, and then we get 22.77 over the I that already given, I1 440 milliampere, and this is 5.51.65 squared. This is the value of R1, and then we apply to this formula, which is X1 over 2 pi F, and then we got 2.51 Henry. And for the equivalent core loss for RC that we already calculate, which is 10.581 kilo ohm, the XM2 4.113 kilo ohm, and then draw the equivalent circuit for the transformer on no load with all the calculate values. And then we're gonna look at the simulation to the result of measurement. Okay, this is the circuit that I already put the value of R2 and L2, and also that voltage that we got previously from calculation is 22.73 volt. We're gonna run the simulation. This is for current I1 440 to milliampere. This is the power factor that we got is 0.91960, and the watt is 10.048 watt, and the voltage is 22.73, and the for current for secondary winding 402.452 milliampere. To adjust power supply until secondary current, and whenever we calculate the voltage, we put this value, and then the result of the current we got is similar to 400 milliampere, which is 402.432 milliampere. And then verify the input power and primary current transmission as the given. Record simulation result in table 3. This is the result. The conclusion is I can conclude that I understand the purpose of open circuit and short circuit test, and I understand the equivalent circuit parameter that they are given, and I can apply it to the circuit, and I understand the summary of the open circuit and short circuit for single phase transformer. I know the theory of the secondary and primary transformer is, and that's all from me. Thank you for watching.